We have been quiet, but we have not been inactive. Improvements we've made to our Longmill table. Stand by. Hey everybody, welcome back to RATTLECAN Fab Shop. I am James, and today we are going to be talking about a couple of improvements that I have made in the table and the way that we are doing things on the Longmill Mark II 30x48. That comes from Sienci Labs, spelled weird because they are up in the Canada, but that's okay. Search Longmill and you will find the website. What we have done is we have played around and we have tested around with this a little bit, enough to kind of figure out where I think I want things to go. So I have done what we would call a hard prototype. I've kind of sketched out an idea of what I wanted in this table. And I just happen to have a whole stack of chipboard sitting over in the corner. And so I have constructed a container for all of our control systems. And I've done a little bit of modification to the table itself to help us apply power. Hello. Oh, yes. The Facebook will be going off because we are celebrating, or kind of commiserating, or remembering, something like that. The fact that we left Japan 10 years ago. It was a great 2 years over there. Probably the only assignment in 30 years that we both agree on we would go back in a heartbeat. Anyways, so here is, let me zoom in a little bit and we'll talk about the first thing that we did. Underneath and on the front part of this table, I have implemented a couple of pieces of equipment to help us with our power. I live in Dayton, Ohio, and it is coming up on storm season. And a lot of times we get wind, and wind will cause things to flicker. And sometimes wind will cause the power to go out. Because I don't know about where you live, the trees where I live are subject to this pesky thing called gravity. They have a tendency to fall down and take power lines down with them. So the first thing that we have is on the bottom, which would be, let's see, right there in that area. That is an APC 1500, what do they call that? 1500 watt hours, volt hours, amp hours. I don't know. It's a big skookum battery in there is what it is. And that is going to do two major things for us. Number one is if the power goes out, it is going to give me enough time to hopefully pause my machine before I drain that battery. And with a router going, it's going to go pretty quick. So that's one thing that it does. The other thing that it does is it will help to clean up our power. Electricity is a sine wave. It's a wave that goes up and down, and it alternates 60 times a second. That's why they call it AC. AC stands for alternating current. So it goes from 110 volts positive to 110 volts negative, back and forth and back and forth and back and forth. And the problem is your power doesn't come in at exactly that. Sometimes, like right now on the front of it, it says it comes in at 123 volts. So what that is going to do is it's going to kind of smooth that wave out so that we have a much more consistent supply of power. It's also going to filter out some of the noise that can come through the transmission lines and come through whatever electrometronics you got going on that is supplying electricity into your shop. So that's the two things that it does. It helps to clean and condition the power to make it more attractive and palatable to our delicate electronic equipment. And in case the power goes out, it's going to give me, I don't know, 2 or 3 minutes to hopefully just get my Z-axis pulled up and get the thing shut off. Because what we don't want is don't want the power to go out and then quickly come back on, because who knows what's going to happen. My guess is we're going to lose a bit. Something's going to snap, a workpiece is going to get ruined. Having that electricity on tap for a very short amount of time after the power goes off, it's just a little bit of insurance that we don't have as big a problem getting this thing started back up after the weather clears out. The second thing you're going to notice across the front is a rack mount switch. It is a surge protector as well as a 9 outlet switch. And I've put that in there just because when I come in, the first session thing that I do when I come in is I turn my computer on, which I can do with the rocker switch, and then I turn the power on to the Longmill, and I unlock my OOPS button, but I don't necessarily turn my router on. I don't necessarily turn my fan on. So I wanted an easily switched supply for my power, and that's what I've done. And I just added a piece of 2x4 underneath my main brace. I cut a notch out for it. We used to use these all the time when I was on the road playing in rock bands, and this was a lot of times you would have a rig for a musician, and they would have all kinds of effects in it. Well, you would run the effects through something like this so that they would have at least somewhat of some surge protection going on, and then they could just easily turn things on and off. So let's reposition here a little bit, and I'll show you what else we've done. Now, she don't look like much, and that's because at the moment she ain't much. This is our controller case. You call it whatever you want to. It's the purpose of this is there's a couple of purposes for it. Number one is to try to keep all the crap out from inside of my delicate electrometronics. Depending on what we're cutting, if it's MDF or if it's acrylic, I'm sure we're going to be doing aluminum before too long. We want to keep those chips and that dust out of our electronics as much as possible. So that is one purpose of this. Another purpose for this is to facilitate cooling. I don't know how much heat this is going to produce when we're running great guns. We've designed it so that if we have to, we can get some ventilation cranked up. And it also makes troubleshooting in case something's going wrong and we got to try to figure stuff out. It makes it a little bit easier if it's not a huge spaghetti mess. I'm going to reposition the camera here, and we'll pull you over and we'll show you what's going on. As promised, she is not pretty. Exhibit 1, chipboard. This is the stuff that comes on cheap shelves. I used to work at a place that used to be a pottery barn. In a room in the back, we had hundreds of sheets of this, and some of it followed me home. The top of this is made out of particle board. You may notice a slight mismatch in the geometry of the top of this. It's just a prototype. It'll be fine, guys. So we're trying to figure out what features we want, what worked and what didn't work, and it's really easy, if I messed a piece up, to just pull another piece off the pile and make another one of these instead of making it out of some, I don't know, some nice, pretty, more likely expensiver wood. So the one thing you might notice is that I have 2 fans down here. These are computer case fans. They are 12 volt DC fans. They run about 1 amp a piece, and they move some air. They're also fairly noisy as far as stuff like that goes. So we'll show you how we did that. You may also notice on the front we have sort of a mesh. This is, I don't think this is what I'm going to use, but this is just a filter. This is actually a washable air filter out of a like an HVAC system. And so this is just here to keep the big chunks from going through our equipment. So the theory is if we reach a certain temperature, let's just call it X. If we reach X temperature, then there's a rocker switch on the front. I can turn that switch on, And lo and behold, I have air being pulled in here, coming through my components, and then being evacuated out of here. So I'm bringing this cooler air through this box, cooling off my equipment. Are we going to need it? I don't know. Is it better to have it and not need it than to need it and not have it? Absolutely. All right, let's tear the top of this off. All right, we'll do this for now, and then we'll switch around a little bit before. Change number one, I have a new computer Au.Ra. Friend of the channel, Jay, if you guys have followed along anywhere, he has secured for us a little mini PC, because even though all I was really running on that old busticated laptop was GSender and a web browser, because I have a common OneDrive, because I'm a student, I have a stupid amount of storage space on OneDrive. And so we were using that as a common area to upload and download test files from. But it was just really slow, because if it had to restart, it took forever. So anyways, we have a new small footprint, much more faster, because this is now a quad-core Pentium system, and I've got room to upgrade memory and stuff if I feel the need to. I control this with this. I have a little USB wart up there on the front, and that connects up this wireless pad. It has a scroll wheel, it has a mouse buttons, it has a little touch pad and stuff like that. So this is what I control. This is what I control my GSender with. I don't know, $19, $20 or something like that on the big online box thing. So our airflow is going to come through here. It's also going to come, I've got about 2 inches on top of that. So some of our airflow is going to come through, and it's going to extract some of the heat away from this unit. I have a little baffle that comes this direction, because this is where the exhaust is, and this exhaust can get kind of warm. And what I'm wanting to do is to keep that hot air from going underneath my Longmill. This is what they call the long board, the CNC control board. There are some heat sinks underneath this control board. And what I've done is I've taken a couple of pieces of maple, because we just got piles of it laying around, and I made a couple of runners, so that raised this control board up off of the surface. So now if I run these fans, then the air, I can actually move this over a little bit if I wanted to. I could scoot it over this direction. There we go. Can open up a little bit more room over here, so we can pull cool air in, and it'll shoot underneath our control board. So we've done a little bit of cable management here. These are the cables for our motors. I have placed them all up in this bundle, and then this is control board. Everything comes in here. When we decide on a final configuration, that is going to have a grommet, a seal of some sort. And then down here on this end, this is all of the wiring for our induction sensors. So it's just a little bit easier to, if you're having a problem with a motor, if you're having a problem with a sensor or something, well, now you know that it's either in this bundle, or it's in this bundle, or it's in all of these connections back on this side. So I'm going to pull around to the other side. We're going to look kind of what's in this downstream bit here. All right, we've changed position a little bit. Our airflow is coming down this direction. This is our controller that we just talked about. This is our USB cable that has the ferrite cores on either end of that, just to give us a, hopefully noise-free signal path. Then I have mounted the power supply for the Longmill kind of up here on this wall. That frees me up a little bit of room here. Also, we're going to get some airflow coming past here. So we're going to pull over here. Down here, this is the power supply. And so this is what is running these two computer case fans. So I've also got just this little bit of a kind of a curved baffle to direct our airflow, make it a little smoother transition, because I've got a 90-degree change of direction in here. That's not really the way I wanted to do it, but I'm really close to this back wall, and I'm kind of tight back in this section of the shop, and I didn't want to just blow air onto this one wall and hope that it got out of the way. So we made a change in direction there, and hopefully it'll work. But so that's what we've done just to kind of contain things. I have a temperature sensor on the way that I'm going to put in here. I don't know. Probably just try to put it right here in the middle. Maybe. I don't know. Do you know a better way? Do you know a better place? I don't know. Do I put it up here on the wall? I don't know. If you got a suggestion, put it in the comment section down beneath sermon notes. Because, I'm just a guy. I'm not a thermodynamicist or one of them engineer type people. I just see if stuff works, and if it does, I keep doing that. And if it doesn't work, then I do something different. So let me know what you think about temperature probe placement for a box like this, so that we can reach a certain temperature. And once we reach that temperature, then we can kick the fans on and make some noise. So anyways, that's kind of where we're at. Now, what are some things that we have to do that we're thinking about changing? So this up here is unsatisfactory. That was just to filter the air coming in, and that's all it does. What I would like to do is figure out a way that I could kick the camera stand, because that's always fun for you guys. Figure out a door front. I guess I could show you this. Take this off. So this is what I have in the front. What do they call that? Hole. Yeah, it's just a hole. So what I would like to figure out is a way that I could put a hinged front on here, have my ventilation hole there, and then have a door that would hinge up, that would hold some sort of filter media, and perhaps have a couple of little T-iny magnets to hold that shut, because at some point I'm going to have to get in here and I'm going to hit the power button. I don't really want to take all that stuff apart to do that. I don't know, if somebody sends me like a Mel Tillis CD, I might have to put that in here. We could listen to it, if we get tired of listening to Jerry Reed. Whoa, negatory, what are you, crazy something? So that's one thing that we're going to do. We're going to think if this arrangement down here with the entry point is going to work, which actually works exceedingly poorly if you can't see it. Trying to figure out if this is going to be acceptable. We will see. We're going to try to do something to get this computer doing stuff. I don't know. We'll figure out some sort of a load test so that we can get some heat generated in there and see if this piece of coroplast is going to do, if we need to replace that with another material, if we need to point it a different direction. Is there a more elegant way to do that back curvature? I'm sure there is. I know we could take a piece of wood and put a million kerfs in it and bend it and, look like Norm. But we'll figure that out when we get to it. So that's what I've spent the past few days working on, getting parts in here. Life has gone nuts right now. We're doing 1.5 million other things as well. I've also just gone through and double checked the square on my machine, and I'm exceedingly close enough for a woodworker, probably close enough for a machinist. So we're good there. I have just done my first little bit of lubrication on the linear rails on my Z-axis. I have just put my first coat of PTFE dry lubricant on my lead screws, and we'll let that dry before we start generating any dust. Was looking for a lubricant that was dry, that wouldn't attract dust, because we're going to generate enough dust as it is. The other thing I'm going to do, I am going to order these lead screws. I'm going to order those from Sienci and get that covered up, because that just seems prudent to me. I found a 90-degree elbow for the dust collection, so that works a little bit better. I have the wall, I have the mount for the television up on the wall. That works okay. We're now kind of, I don't know, we're kind of okay-ish with this. So I think we're going to run with it like this for a little while. We're thinking about the enclosure. We've known from the beginning that we're going to build an enclosure around this. But now we have a couple of different things that we have to think about. We have to think about that smattering of wireness going on there. And we are really tight right here. I can fit an 800 thou piece of wood in between the edge of this MDF rail and the inside or the outside wall of that box. And the other problem I have is there is a stepper motor right there that intrudes into that space. So do we build a sidewall and then do we notch it out? I mean, we could do that, but at the moment we're sketching stuff out, trying to work with the space we got. So now that we're here, the dust collector is going to go back in there. The dust collector, I'll put a picture of it up here. I've enclosed the sides of the dust collector. There is plenty of airflow through there. I've got some holes in the top. I've got an exhaust hole in the back. So I'm not worried about creating any additional heat buildup in that. But it's quieter. I mean, we've still got a freaking router screaming at the speed of heat next to it. But then I've also got a little pancake compressor that we can sit right there for the moment until I get a fitting, because over there where you can't see, just pretend you can see over there. I've got an outlet over there for an air hose so that I can, well, clean my collets out every time I change a bit. That's what we've done. We haven't done any fancy pieces. We've just been checking stuff, and then starting tomorrow, we are now going to, since I've just checked my square, one at a time. Every one of these is going to come out. It's going to get a piece of a little application of blue Loctite on it. It's going to get screwed back in, and then it's going to get a little blue dot to let me know that I have put my Loctite on there, and to remind me that I've done that, so I don't take it out and put it on again, because that's embarrassing. Anyways, I'm James. This is RATTLECAN Fab Shop. I know it's a lot of talking, but this is all prep work that you need to do before you can really start really doing stuff. And then when I'm not doing this, stuffing my face full of YouTube and Fusion 360. And right now, I think we're going to use Inkscape to take bitmaps and JPEGs and convert those into SVGs, which we can then use to import and make a shape. Yeah, and welcome to my life. Anyways, that's what's going on. If you think we've earned it, give us a thumbs up. Consider subscribing. Hit that notification bell so you know the next time the goofy guy does something and over explains it, because that's all I know how to do. And I am going to go have some sort of a beverage before I go to bed, and then we'll be back in the guitar shop tomorrow at the day job, hammering out. What am I doing? I think I'm doing stainable, so it's maple and alder with stripes of whatever I have on the shelves. Could be cherry, could be walnut, could be wingay, could be sapele, could be Pyle, could be flamed maple. Yeah, make all kind of Purple Heart. Yeah. Anyways, you guys have a great weekend. Remember, get out into the shop and do something, even if it's nothing more than just cleaning your crap up. I'm James. Have a good one. Cheers. Thanks for taking the time out of your day to spend it here with me. Hope you enjoyed this video. Here's one that you might enjoy as well. If you're not already subscribed, be sure to hit that button, hit the bell next to it so that you get a notification when we drop a new video. If you've got comments, put them down beneath the sermon notes. And remember, if I can do it, you can do it. You guys have a great weekend. Cheers.